Welcome back. It's good to see you here for another section in Exploring Space. Today, we'll try to understand key activities and current trends that shape what we do in space. Last time, we talked about entering space, how people first thought about space, and how we physically went to space. In this section, we'll discuss Space Comes of Age by describing recent events and trends in the space community, as well as the international environment, space science activities, military efforts, and finally, our future in space. You can see in this outline of Section 3 that we're going to talk about the Air Force's role in exploring space. But now, we'll begin with Space Comes of Age. Let's discuss some of the major trends in space. We know the 1990s helped set the stage for future space activities. Through the Hubble Space Telescope, the Mars Pathfinder, and other missions, we've made discoveries we never imagined possible. Military, scientific, and commercial uses of space increased dramatically with improved technology and the ability to see our planet, as well as the planets in our solar system and galaxy. We'll look at Space International, which gives us a unique view of how the U.S. and other countries are cooperating on space missions for the common good. Under Space Science Big and Small, we'll overview missions that cost a lot and meet multiple mission goals versus lower-cost missions that focus on fewer activities. The new high ground gives us the big picture we talked about in the first lesson. Our ancestors went to the highest hill or mountain to get a better view and plan strategically. Today's ground includes outer space, so we'll talk about how spacecraft give us new information for planning and strategy. And in the future, we'll discuss where we go next, how we get there, why we even want to go, and what we hope to accomplish. We have lots of ground, or should I say, space to cover. So let's get started. When you think about the international space community, what would you say is one of the most interesting benefits? If you said increased cooperation, you'd be right. Cooperative missions have made exploration more accessible and affordable and have forged lasting bonds with other nations. Before Mir returned to Earth in 2005, the U.S. shuttle docked with Mir 11 times and put 7 astronauts on board to live. Russia and the U.S. partnered to redesign our space station Freedom and built it as the International Space Station. Eventually, this partnership grew to include cooperation among 16 nations and set the stage for other space programs. After the former Soviet Union broke apart, cooperation between the two remaining space powers became possible and necessary. U.S. astronauts had access to space with the space shuttle and could live on board the International Space Station shown on the right. The Russians could reach their outpost Mir in a low Earth orbit shown on the left using one of their reliable Soyuz launchers. By combining these assets, both countries have achieved important scientific, technical, and operational goals. It seems as though space is one of the few places where people from many nations can work as a team, benefiting all countries. By the way, look carefully at the Mir photo on the left to find the cosmonaut peering through the window. In 2003, the Chinese joined a very short list of countries that have put a person in space. On 15 October 2003, the Chinese put their first astronaut into space, using the launch vehicle and modules shown here. You already know we call our space crews astronauts. The Russians are called cosmonauts, and the Chinese are called taikonauts, which means travelers in space or cosmos. Now that we understand the benefits of international cooperation in space missions, let's look at big science missions versus small missions. Can you name one of the largest science spacecraft of the late 1990s and early 2000s? One of the biggest and most visible spacecraft in the night sky is Hubble Space Telescope, which we'll discuss in a few minutes. The less well-known Magellan is larger and more expensive. Smaller and less expensive missions are showing their worth as well. They're especially useful when budgets decrease and leaders ask for faster, better, cheaper space missions. Let's focus on Magellan, Galileo, Ulysses, Cassini, and Hubble for our study of big missions. The big missions in the U.S. have enjoyed large budgets and national or military priority. The knowledge and information they brought and continue to bring us is remarkable. We'll start with Magellan, which used a special radar to look beneath Venus's atmosphere and map 98% of its surface. From its launch in 1989 until its loss in 1994, Magellan took in gravity data and did windmill experiments, plus the spectacular mapping of Venus. This photo of the Mat Mons volcano shows the active volcanic eruptions typical on Venus. Many volcanic eruptions and the greenhouse effect trap heat inside Venus and make it one of the hottest places to go on a tour of our solar system. After Venus, our scientists wanted to explore Jupiter, so we launched Galileo in 1989. This spacecraft captured the first close-up photos of asteroids on its way to Jupiter, studied how the comet Shoemaker-Levy 9 affected the planet, and released a probe into Jupiter's atmosphere. This probe told us that the planet had winds up to 350 miles per hour and a surface temperature of 700 degrees centigrade, much too hot for human exploration. But it suggested water existed on Jupiter's moons, Europa and Callisto, an exciting discovery. Galileo also examined the moon Io as it flew close to Io's surface. Though a failed antenna nearly crippled Galileo, an improvised repair made it possible to meet 70% of the mission objectives. That's not perfect, but NASA considered it a major success because no mission had examined Jupiter at this close range. Here we can see Galileo with Jupiter behind it and the moon Io in front of it. The artist's drawing shows how Galileo looked during its fiery entry after completing its mission. Now we'll take a look at Ulysses, which was built by NASA in cooperation with the European Space Agency, or ESA. The mission goal of Ulysses was to study the sun, the source of energy and life for our planet. As Ulysses flew over the north and south poles of the sun in 1994 and 1995, and again in 2000 and 2001, it measured the solar corona, solar wind, and other properties of the sun. As of October 2006, Ulysses has had 16 years of continuous operation. In 2004, Cassini, also called the Cassini-Huygens mission, reached Saturn, where it sent a probe to the surface of Saturn's Earth-sized moon, Titan. Considering the cost, this may be the last mainly U.S.-sponsored probe, although NASA, the European Space Agency, and the Italian Space Agency cooperated on it. In fact, this mission is a great example of how international cooperation can succeed. Since arriving at Saturn on July 1, 2004, Cassini has sent stunning photos and scientific data. In the most recent update, Cassini scientists are on the trail of the planet's missing moons. They believe they'll find the moons near newly discovered rings around the planet. Look at this amazing photo, which shows Saturn sheltering Cassini from the sun's glare. During this unprecedented event, Cassini scientists discovered 2 new rings around Saturn and confirmed the presence of 2 others. The new rings are associated with 1 or more small moons, with which they share orbits, and scientists suspect a moon is lurking near a 3rd ring. Each of NASA's centers has a charter or set of goals for every mission, and the Hubble telescope was no different. Each center has contributed to Hubble's amazing discoveries. The telescope has documented events we knew about but couldn't prove, such as the birth and death of stars, black holes, and the chemical makeup of Saturn's moons. With Hubble's help, we can more precisely measure the size and age of the universe. It's hard to stop talking about NASA's Hubble Space Telescope because of its continuously incredible discoveries. In fact, to extend Hubble's mission, the Space Shuttle repaired it several times during the 1990s. Hubble has discovered 16 planet candidates orbiting distant stars in the central region of our Milky Way galaxy. This extraordinary discovery set off a scientific debate about the definition of a planet. Hubble also has peered at 180,000 stars in the crowded central bulge of our galaxy, 26,000 light-years away. That's 1/4 the diameter of the Milky Way spiral disk. But if you think that number is impressive, consider the possible 50 billion galaxies in our universe. Even though Hubble is a big mission in terms of time, money, and resources, it has surpassed all other space missions with its information and science. Now, let's look at some of those smaller missions we mentioned earlier in this section. Stardust is the first U.S. mission dedicated to exploring a comet. It's also the first robotic mission designed to return material and take photographs from outside the moon's orbit. During its encounter with the comet Wild 2, named after the comet's Swiss discoverer, Stardust had nearly 4 years of space travel, returning to the U.S. by parachute in January 2006. Like other NASA projects, Stardust was a joint effort with university and industry partners. Another great success for the U.S. was the Mars Pathfinder, a technology pioneer. We built and used a Land Rover robot to probe Mars' surface. It returned sharp images of the landscape, including this exciting view of Mars' Twin Peaks. This little go-kart type vehicle was a hit with the public. Its website has more than 100 million hits a day. You may want to look yourself. The Pathfinder also applied an easy, low-cost landing using simple airbags as cushions. 2 other small missions are important to mention. The Lunar Prospector discovered large amounts of ice on the moon, which will become vital if we decide to place a colony on the moon. And the Near-Earth Asteroid Rendezvous, or NEAR, has transmitted up-close imagery and data from the asteroid Eros. Sometimes people explore space using their talents to meet mission objectives. But most space exploration requires robotic spacecraft that can survive the harsh space environment and send us incredible information, images, and science. In our efforts, governments and companies work together to get the job done. Now let's think about a really exciting new phase in the space industry. In the early 1990s, for the first time ever, companies spent more than governments in space. Several large commercial telecommunications projects, such as Iridium and Global Star, have since gone bankrupt. But industry continues looking for ways to use space to better our lives. For example, the Global Positioning System, or GPS, can tell us where we are anywhere on or slightly above the Earth. It gives us exact positions in cars, boats, or on foot. Even during rebuilding of Hurricane Katrina areas, GPS made locations of damaged areas more precise. It's so successful that companies in other regions like Europe and Asia are developing their own navigation satellite systems. Communications satellites handle over 1 billion users of the World Wide Web, and if we informally surveyed this classroom, we'd probably find that 9 out of 10 of you own a cell phone. Most of the 550 or so operational satellites in orbit around Earth support telephone, television, and radio communications. Companies that can launch satellites often sell their vehicles and services to government and commercial organizations. Remember, when we talked about our ancestors going to higher ground to get a better look at the area around them? In the same way, our communication spacecraft allow us to use the high ground of space for peaceful and not so peaceful purposes. In the early 1990s, the Persian Gulf War showed how pivotal space assets are in modern warfare. Space capabilities have allowed us to navigate across faceless deserts with the help of GPS and to detect and intercept enemies' launches of tactical missiles using the Defense Support Program. Our weather satellites predicted sandstorms so our troops could seek shelter, and intelligence satellites gave us accurate, reliable imagery on troop movements and battle damage. The military uses space assets of every kind to support soldiers in the Iraq War. Let's think about some other ways the U.S. Air Force might use our space power. To support troops or weapons deployed all over the world. Satellites give us the command, control, and communications for weapons targeting. Here you can see a Defense Support Program satellite and a GPS satellite that supported our troops in Operation Desert Storm, our first Gulf War, the Persian Gulf War, and the War on Terrorism. So, what does the near future hold for us? Space remains a source of untold possibilities and wonder. Still, the 1986 Challenger and 2003 Columbia accidents are painful reminders of its risks to people and equipment. But many people will take on these risks to better mankind. How would you feel about going on a mission knowing your life was in danger but believing strongly in its goals? NASA and our allies in space will continue scientific experiments on board the International Space Station. They will continue robotic missions to other planets to gather information that will change our knowledge of the universe. Our Department of Defense will continue to find ways to protect us against aggressors. But what does the 21st century hold for us? Is a crewed mission to Mars possible? Think about this now, and after working your way through the following chapters, see if you feel the same way. In early 2004, NASA was directed to become more aggressive in exploring our solar system. The administration asked NASA to complete the International Space Station as soon as possible, retire the space shuttle, and develop a new crew exploration vehicle that can go to the moon and beyond. Now let's answer the first two questions on this slide. They should be easy for you. Next, split into two groups and discuss what role you can play in the Air Force space community or in NASA as an astronaut or as a member of a ground support crew. Remember, there's no right or wrong answer. It's just a chance to make sure you understand the material and to get you thinking about the future of space. In this clip, you'll see what it took to place the Mars Pathfinder rover on the surface of Mars. The spacecraft will launch and go through many activities to get the capsule holding the rover to Mars. It takes about 259 days to get to Mars from Earth on a normal trajectory. You'll see the spacecraft enter the Martian atmosphere, slow down using a parachute, and land in a group of airbags that seem to bounce forever. Next, you'll see the Mars Pathfinder rover deploy its systems, leave the safety of the airbags, and move around on the surface of Mars, taking rock samples.
SSC disconnect enable on.
35. Let guys go. Hydraulics go.
EC pressurized vehicle locks tank.
Pressurizing.
SSC hydraulic pump control on.
On.
CLCDR pad B deck flush on.
On.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine ignition, and liftoff of the Delta II rocket with the Mars Exploration Rover.
Rover program response is good.
Here you'll see a spoof of the Mars Pathfinder mission that Hewlett-Packard has used in a European commercial.
Vigy balra 20 fokkal.
Csodálatos bolygó.
Csak egy kissé unalmas.
Fotóminőség minden papíron. Fotored 2. Csak a Hewlett-Packardtól.
In the next section, we'll move on to organizing the Air Force for space operations. All of you are taking this course to understand aerospace science. But in this next section, we'll talk specifically about the Air Force in space. After looking at how the Air Force became involved in space, we'll discuss its organization in the beginning of the 21st century.